Train an AI only on correct answers, and on hard problems, it can end up exponentially worse because it never once sees a wrong turn, so it never learns how to back out of one.
Hold on, feeding it only correct answers makes it worse? Okay, take a guess. How much slower is that clean-taught AI on a really deep problem? Twice? 10 times? Lock in a number. The real one keeps growing the deeper the problem gets.
And keep an eye on one strange detail: the middle of the maze. Early in training, the method that wins does something there that looks completely backwards. That's not a bug, and it matters.
A maze? That's the model of thinking here?
That's it. Two researchers, in a paper out this June, turned reasoning into finding your way through one. Picture a fork that splits into a bunch of long corridors. Only one leads home.
So the AI picks a corridor, and if it's wrong, it has to walk all the way back and try another.
Right. So the whole game is backtracking. And every reasoning AI you've heard about, the ones that think step by step, gets trained one of two ways. This paper proves those two ways teach wildly different things.
But my gut says, show it perfect examples. Clean, correct solutions. That's got to be the best thing to learn from.
That's exactly the belief this breaks. Way 1, copy the expert. You show the AI one perfect walk. Pick the right corridor, march straight home, never reverse. It imitates that. But a perfect walk has no wrong turns. So the AI never once sees a dead end in training.
So the part that handles, I'm stuck, turn around,
Never gets practiced. It stays exactly as clumsy as day 1. You can't learn to fix a mistake you're never shown making. Now, way 2, let it try itself. The AI wanders in, picks wrong corridors, gets stuck, claws its way back out, and gets rewarded only when it reaches home without wasting steps. So it practices backing out constantly. And hold on to one thing. None of this is really about the copying method itself. That pays off at the end.
So why exponentially worse and not just a little worse?
Picture backing out of a wrong corridor. At every step, a handful of lanes tempt you forward, deeper into the dead end, and only one lane continues your retreat. For the untrained AI, it's a coin toss stacked hard against escape. Backing out is swimming upstream against a current that sweeps you back most of the time.
And a long corridor is a long swim.
And here it compounds. Each extra step of depth doesn't add to the escape time. It multiplies it, about fivefold in their setup. The try-it-yourself AI's cost grows gently. The copycat's cost explodes.
Okay, but is this just chalkboard math, or did they check it?
They ran it, the toy model, a real reinforcement learning method, and a small neural network. If the theory holds, the try-it-yourself model should land right on a predicted number. It did. Around 900 steps, dead on. And the copycat? Its cost ran off the chart, the exact exponential blow-up the proof predicted.
Wait, so my guess? 10 times slower?
Not even close. There's no fixed multiplier. The gap keeps widening the deeper the reasoning goes. It grows without limit.
And that weird middle of the maze thing?
The winning method briefly shoves some middle corridors the wrong way early on. It gets worse before it gets better, right in the middle, before the whole thing snaps into place.
Here's the honest bit. This is a spotless toy maze, built to make the gap huge. Real training data already has some mess in it. So treat this less as a photo of real AI training, more as a stripped-down lab test of what the clean version can't do.
Fair, and that mess is the fix. Take the try-it-yourself model's transcripts, wrong turns and recoveries and all, and have the copycat imitate those instead of tidy textbook answers. Suddenly, it learns to back out too. The failure was never copying. It was training on data with no mistakes in it.
So the best study guide isn't the cleanest one.
It's the one that shows you how to be wrong and how to recover.
So chew on this. If you were teaching anyone, a kid, an AI, would you hand them flawless examples or messy trial and error with every dead end left in? Drop where you land in the comments.
And if you like watching one AI paper cracked open into plain English, subscribe. There's a fresh one every week. And the next will catch you off guard just like this.
Good reasoning isn't knowing the right road. It's knowing what to do when you're on the wrong one.